Ever get that like blank mind feeling when you're coding?
Oh, yeah.
It's like you're just staring at this problem
Yeah,
and your brain just decided to like take a vacation without you
totally.
and you're just like stuck.
Uh-huh.
Well, we are tackling that very feeling today.
Right.
We're going to be diving into some strategies that you shared with us actually from the Algo Academy blog. It's called Overcoming the Blank Mind Syndrome: How to Start Solving a Problem When You Have No Idea.
Catchy title.
Yeah. So get ready to unlock your inner coding ninja as we break down 3 techniques that they highlight in the article:
Okay.
problem restatement,
All right.
hypothesis generation,
Okay.
and simplifying assumptions.
Sounds good.
I'm excited.
Yeah, me too.
It's going to be fun.
It's amazing how these techniques apply like far beyond just coding, though.
Oh, yeah.
Yeah. Think about any problem that just makes you feel stuck.
Uh-huh.
These same strategies can help you to kind of like gain a foothold
Okay.
and start making some progress.
Yeah, I like that. So it's kind of like what? Mental cross-training.
Yeah, exactly.
Sweet. But before we jump into the solutions,
Okay.
let's paint a picture of the problem.
Yeah.
The article outlines some common triggers for this, these blank mind triggers. In coding,
Mm-hmm.
we're talking about those moments when a problem seems overwhelmingly complex,
Yeah.
or the clock is ticking away,
Right.
or you're just mentally fried. Any of this sounding familiar?
Absolutely. And it is often like a combination of factors too, right?
Yeah.
Complex problems under time pressure. I mean, that can lead to fatigue.
Right.
It makes it even harder to think clearly.
For sure.
So the first step to conquering these mental blocks
Yeah.
is simply recognizing what triggers them.
Okay, so let's dive into the first technique.
Go. Problem
Restatement.
Yeah.
It's kind of like explaining something to a rubber duck.
Okay.
Only instead of a duck, you're explaining it to yourself,
Right.
hopefully out loud,
Yeah.
so that your roommates don't get
I'm
worried.
going to say.
Right.
Yeah.
But there's a real art to that, though, right?
Yeah.
It's not just like repeating the problem verbatim.
Yeah.
It's about reframing it in a way that highlights the core objective and strips away the mental clutter.
Yes.
The two-sum problem example from the article is a perfect illustration of this.
Okay.
The original problem wants you to find the indices of 2 numbers in an array that add up to a target.
Okay.
So you have your target number,
Uh-huh.
and you have to find the 2 numbers in the array that add up to that.
Right.
But if you restate the problem as find 2 different positions in a list where the numbers at those positions add up to a specific total,
Okay.
suddenly you're not fixated on the numbers themselves,
Interesting.
just thinking about their locations.
Right.
That's really interesting. I can see how like just a tiny rewording can unlock
Yeah.
a whole new way of seeing the problem.
Exactly. The restatement should maintain the original problem's essence. Right. But presented in a way that just clicks better with your thinking style.
Totally. Okay, so let's move on to the next technique. Hypothesis generation.
Okay.
This is where we unleash the brainstorming beast.
Right.
The article emphasizes not judging ideas at this stage. Just let those potential solutions flow freely.
Yeah. Yeah. Let them
It's like sketching out potential blueprints.
Okay.
Before you even pick up a hammer,
Right.
you might explore several paths
Yeah.
before finding the one that leads to a solid structure.
I like that.
They use the finding the maximum Subaru sum problem to illustrate this.
Okay.
And the article lists 4 potential hypotheses:
Right.
brute force, divide and conquer, dynamic programming, and Kadane's algorithm.
Wow.
Now, I'm guessing some of these are more efficient than others.
Probably.
But the point is to explore the options right.
Absolutely.
Mm.
And even an incorrect hypothesis, that can be illuminating.
Okay.
It can reveal limitations,
Okay.
highlight those edge cases, or even spark like a completely new line of thinking.
Oh, wow.
For instance, brute force, that might seem naive,
Yeah.
but it's often a great starting point just to understand the problem's structure
Okay.
before diving into like more sophisticated solutions.
Right.
On the other hand, something like Kadane's algorithm, I mean, that's known for its efficiency,
Right.
but might require a deeper understanding of the problem's nuances.
Okay, so it's like having a toolbox
Yeah.
full of different problem-solving tools.
Right.
You don't need to use every tool for every problem.
Yeah.
It's about picking the right tool for the job.
Exactly. Each technique has its strengths and weaknesses,
Yeah.
and knowing when to apply which one. I
Right.
mean, that's a skill honed through practice and experience.
Absolutely. All right, on to our final technique for this part.
Okay.
Simplifying assumptions.
All right.
This is where we break down a monstrous problem into bite-sized pieces.
Okay.
It's like saying, okay, world, hold on, let me handle this one step at a time.
There you go.
Right.
Yeah.
And sometimes that step-by-step approach is the only way to make progress.
Right.
Think of it like building a complex machine. You wouldn't try to assemble every part at once, right?
Oh, no.
You'd start with a simplified model,
Yeah.
focusing on the core components.
Yeah.
Before adding the bells and whistles,
Yeah, right.
they use implementing a cache with a limited size as an example for this.
Okay.
Instead of diving headfirst into like the intricacies of eviction strategies
Right.
and limited sizes,
Uh-huh.
they suggest starting with the simplest version possible,
Okay.
unlimited size, no eviction, and basic string keys values.
Okay.
Why would we intentionally make it easier than the actual problem?
Well, because that initial simplified version
Okay.
gives you a solid foundation to build upon.
Okay.
Once you have a basic key value store using a hash map,
Mm-hmm.
you can incrementally add the complexity.
Okay.
First, a size limit,
Mm-hmm.
then an eviction mechanism, and finally, the specific LRU eviction strategy.
Okay.
It's much easier to manage complexity in layers than trying to tackle it all at once.
Okay. So to wrap up part one, we've got our three trusty techniques: problem restatement, hypothesis generation, and simplifying assumptions. It sounds like they're less about finding the right answer immediately and more about breaking down mental barriers and getting those problem-solving gears turning.
Exactly. These techniques are all about shifting your perspective,
Okay.
generating possibilities, and making the complex feel manageable.
I like it.
Yeah, stay tuned for part 2, where we'll see how these techniques play out in some real-world coding scenarios that you shared with us.
Awesome. I can't wait.
Welcome back to our deep dive into banishing blank mind syndrome. In part 1, we unpack the 3 techniques from the Algo Academy article: problem restatement, hypothesis generation, and simplifying assumptions. Now let's see these techniques in action, using the real-world scenarios that you shared with us.
I'm excited to put these techniques to the test. Our first scenario. You're in a technical interview, and you've been asked to find the shortest path between 2 users in a social network represented as a graph. Now, you're no stranger to graph algorithms, but in a high-pressure situation like this,
Oh, yeah?
it's easy to get flustered.
Absolutely. Even experienced developers can freeze up in an interview. But remember, the interviewer isn't necessarily looking for you to spout out the perfect solution instantly. They want to see your problem-solving process, how you think critically and apply your knowledge. And this is where problem restatement can help you
Okay.
to stay grounded and focused.
Okay, so instead of getting bogged down in the technical jargon of shortest path, we could say, how can I figure out the minimum number of friendship connections needed to link these 2 people?
Exactly. By reframing the problem in simpler terms, you connect it to something more relatable. Plus, it might spark some ideas about which algorithms are best suited for this type of problem.
Right. It's like I'm not just thinking about abstract nodes and edges anymore. I'm actually picturing people.
Yeah.
And
Yeah.
their connections
Yeah.
in a social network.
Yeah.
So what comes next? Hypothesis generation.
Precisely. Now that you've clarified the goal, start brainstorming potential approaches. Think about the graph algorithms you know. Could something like breadth first search, BFS, or depth first search, DFS, help you find that shortest path?
I remember that BFS is generally good for finding the shortest path in unweighted graphs.
Okay.
Right. So since we're just looking for the minimum number of connections and not considering things like distance or weight, maybe BFS is a good starting point.
That's a great observation. And you've already incorporated simplifying assumptions without even realizing it.
Okay.
By assuming an unweighted graph, you're reducing the problem's complexity and focusing on the core logic of finding connections.
Ah, I see. So even before writing a single line of code, these techniques are already helping me narrow down my approach and focus on the most relevant aspects of the problem.
Exactly. Now, let's move on to our second scenario, which involves designing a URL shortener. This feels like a whole different beast compared to a graph problem.
Yeah, no, right? It seems so much more complex.
Yeah.
We're not just dealing with an algorithm, we're designing an entire system.
Right.
Where do we even begin?
Well, the beauty of these problem-solving techniques is that they're adaptable to different situations. Just like with the graph problem, let's start with problem restatement.
Okay.
How can we distill the essence of a URL shortener without getting lost in the technical details?
At its core, a URL shortener takes a long, messy URL and transforms it into a short, unique code that redirects users to the original link. It's like creating a secret code for each web page.
Exactly. You've hit the nail on the head.
Okay.
By focusing on the core functionality,
Okay.
mapping long URLs to short codes.
Right.
You've simplified the problem significantly. Now, with the objective clear, let's move on to hypothesis generation. What are some ways to generate these short, unique codes?
Well, I know that some URL shorteners use hash functions to generate those short codes. It's like taking the original URL, running it through a mathematical formula, and getting a shorter, seemingly random output. But wouldn't we need to handle potential collisions where two different URLs end up with the same short code?
You're absolutely right. Collision handling is a crucial aspect of URL shortener design.
Right.
Techniques like appending random characters
Okay.
or using a counter-based system can help mitigate that risk. And remember, at this stage, we're just brainstorming, so don't dismiss any ideas just yet. Perhaps a counter-based system where each new URL gets a unique sequential code could be worth exploring.
Okay. So hash functions and
Wow.
counter-based systems are two potential approaches. I'm starting to see how hypothesis generation helps us consider multiple options before diving into the implementation details. But before we get too carried away, should we try simplifying assumptions?
Excellent point. Building a full-fledged production-ready URL shortener, that's a complex endeavor involving databases, servers, load balancing, and all sorts of other considerations. So to make it more manageable, let's start with a simplified model.
So for instance, we could initially assume that we're only dealing with a single server, ignoring the complexities of distributed systems and scalability for now, and maybe we can start with fixed-length short codes to simplify the generation and storage process.
Exactly. By setting aside those complexities for the time being, you can focus on the core logic of mapping long URLs to shortcodes and back. Once you have the basic functional system, you can gradually introduce those advanced features and address issues like scalability and code length flexibility.
Okay, I'm starting to see how these techniques work together, like pieces of a puzzle. We clarify the objective, we explore possibilities, and we simplify the problem space to create a solid foundation. And then we can gradually add complexity as we go, like building a house brick by brick.
That's a great analogy. Now, for our final scenario, let's tackle the world of algorithm optimization. You mentioned feeling intimidated when asked to make code faster, and that's a sentiment many developers share.
I know that performance optimization is crucial, but it can feel overwhelming. It's like someone is asking me to squeeze more speed out of a car engine when I barely understand how it works.
That feeling is completely understandable. But just like with our previous scenarios, let's apply our techniques to break down this seemingly daunting task. First up, problem restatement. Instead of fixating on the technicalities of algorithms and benchmarks, how can we rephrase the problem in a way that captures the essence of optimization?
Well, fundamentally, it's about minimizing the time it takes to complete a specific task. In the case of search optimization, we want to find the relevant information as quickly as possible, right?
Precisely. You've identified the core objective, reducing the time it takes to find a needle in a haystack of data. Now, let's move on to hypothesis generation. What are some potential strategies we could explore to make those searches faster?
Well, I know indexing is a common technique for improving search performance. It's like creating a table of contents for our data, allowing us to quickly jump to specific sections instead of scanning through the entire data set. And I've heard about different data structures like hash tables and B trees. That can offer faster lookups compared to simple arrays or lists. Oh, and caching. Storing frequently accessed data in a readily available location, like memory, can also speed things up.
Excellent brainstorming. You've identified several key optimization techniques: indexing, data structures, and caching. Now, before we dive into the specifics of each technique and how they might apply to your particular problem, let's consider simplifying assumptions.
Okay, so instead of trying to optimize for all possible scenarios right away, we could focus on a single search criterion, like assuming users primarily search for products by name. And maybe we can initially focus on optimizing for in-memory operations, ignoring the complexities of disk access or database interactions.
Exactly. By making these simplifying assumptions, you're creating a more manageable problem space. And you mentioned assuming a static dataset, which is another great way to simplify things initially. You can focus on optimizing the search for a fixed set of data before tackling the complexities of handling real-time updates.
This is starting to make a lot of sense. By applying these techniques, we're not just blindly throwing optimization techniques at the problem. We're taking a strategic, step-by-step approach, building our understanding, and refining our solution along the way.
And that's what these techniques are all about: empowering you to approach complex problems with confidence and a clear plan of attack. Stay tuned for part 3, where we'll explore how to integrate these strategies into your everyday coding life. and make them a natural part of your problem-solving toolkit.
Welcome back to the final part of our deep dive into conquering blank mind syndrome. We've explored the three techniques from that Algocademy article: problem restatement, hypothesis generation, and simplifying assumptions. And you even walked us through how they could apply to some real-world scenarios. But now comes the real challenge. How do we make these techniques stick so they become second nature in our coding lives?
It's like learning a new dance move.
Okay.
You can watch someone do it 100 times, but until you get on the dance floor and practice it yourself, it's not truly yours.
Yeah.
These problem-solving techniques are the same way.
The article had some great advice on turning these techniques into habits. Practice, of course, is key. But it's not just about mindlessly grinding through coding problems.
Exactly. It's about being intentional with your practice.
Okay.
Choose problems that challenge you, push you outside your comfort zone, and force you to apply these techniques consciously. Think of it like weight training for your brain.
Okay.
You need to progressively overload those mental muscles to see real growth.
I love that analogy. So instead of just going through the motions, we should actively think about which technique is most appropriate for each situation and why. And maybe even document that process, right? The article mentioned keeping a problem-solving journal.
Journaling is a fantastic way to solidify your understanding.
Okay.
It forces you to articulate your thought process, identify patterns in your problem-solving approach, and recognize areas where you tend to get stuck. Plus, it's super satisfying to look back and see how far you've come.
I can see how it would be helpful to have that record of your past struggles and triumphs. It's like a map of your coding journey, showing you where you've been and where you're headed. And speaking of journeys, the article emphasizes the importance of embracing the struggle.
So often we try to avoid feeling stuck.
Right.
We see it as a sign of weakness or failure,
Yeah.
but getting stuck is an inevitable part of the learning process, especially in a field as complex as coding.
It's like trying to climb a mountain. There are going to be moments where you feel like you're not making progress, where the path ahead seems unclear. But it's those moments of struggle that ultimately make reaching the summit so rewarding.
Exactly. Instead of getting discouraged, use those moments as opportunities to apply these techniques.
Oh.
Reframe the problem, brainstorm possibilities, and break it down into smaller steps.
Right.
You might be surprised at how often a seemingly insurmountable obstacle crumbles when you approach it with a clear head and a systematic plan.
It's like that saying, the only way out is through. And sometimes the best way through is with a little help from our friends, right? The article also highlights the value of collaboration.
Absolutely.
Mhm.
Talking through a problem with someone else can spark new insights,
Yeah.
expose blind spots in your thinking,
Uh-huh.
and help you get unstuck when you're feeling lost. It's like having a second pair of eyes on a complex puzzle.
Yeah.
Sometimes all it takes is a fresh perspective to see the solution.
And even if you don't have someone to collaborate with directly, there are tons of online communities and forums where you can connect with other developers, share your struggles, and learn from each other's experiences.
Those online communities can be invaluable resources. They offer a sense of belonging,
Right.
a place where you can ask questions without feeling judged,
Yeah.
and a wealth of knowledge and support from people who've been there and done that.
So to recap, we've got practice, journaling, embracing the struggle, and collaboration. These are the habits that will help us turn these problem-solving techniques into a natural extension of our coding instincts.
And remember, these techniques are not just about becoming better coders. They're about developing a problem-solving mindset that extends far beyond the realm of programming.
It's like we're not just sharpening our coding skills, we're upgrading our mental operating systems, making ourselves more adaptable, resilient, and creative problem solvers in all areas of our lives.
The Algocademy article concludes with a powerful statement. The ability to tackle unfamiliar and complex problems is what sets great programmers apart. And that ability is not some innate talent. It's a skill honed through practice, perseverance, and the right techniques.
And you know what's even more inspiring? That skill is available to anyone willing to put in the effort.
Absolutely.
So the next time you find yourself staring at a blank screen, heart racing, doubt swirling, take a deep breath, remember these techniques, and start breaking down those mental barriers.
The path to a solution might not always be obvious, but with the right mindset and a systematic approach, you'll be amazed at what you can accomplish.
And hey, we'd love to hear about your problem-solving triumphs and maybe even some epic fails along the way. Share your experiences, connect with other learners, and keep that coding fire burning. Until next time, happy coding, everyone!